welcome everybody back to the ONTOBRAS 2021, this year by the Federal University of Espírito Santo. Now we start with the technical, the keynote session, and I will introduce you João Paulo Almeida. João Paulo will give us a talk, Building Better Ontology Implementation with gUFO. And João Paulo is associated professor at the Federal University of Espírito Santo, is a senior member of the Ontology and Conceptual Modeling Research Group NEMO, and the CNPq Productivity Research Fellow. Since 2007, he has been working on the application of ontology in enterprise architecture and conceptual modeling at the NEMO group in the Federal University, having had a key role in the development of the ONTO-UML language and associated model-driven tools, as well as the MLT, multi-level modeling theories, the ML2, multi-level modeling language, and associated tools. He served as a member on the executive committee of the International Association of Ontology and his application in 2016, and has a chair of the IEEE EDOC Conference Steering Committee. He currently serves as editorial board of the Journal of Applied Ontology, is a senior member of the IEEE and ACM. Welcome, João Paulo. It's your moment now, and have a good talk.
Thanks, thanks, Mara. Thanks a lot. So Mara mentioned that I had a key role in the development of ONTO-UML and related technologies. One of these key roles was to annoy Giancarlo when we were office mates back in the University of Twente. So he was always telling me all these things about ontologies that was back in 2002. And I was the skeptical guy in the room, you know, the computer scientist guy that just looked at that, all kinds of very strange jargon and philosophical terminology making its way into computer science. And I found that very weird. So I was always asking him the annoying questions. But so then I understood that these were key things that he was talking about, and found out this world of reference ontologies and foundation ontologies in particular. So this is a talk where I'm going to try to distill some of these things that I've learned throughout these years from applying foundation ontologies, and more recently from applying them in a setting where we want to build ontology implementations with semantic web technology. So these ontologies, they can be better than what we're currently doing without support, or with the support we have. And we thought of adding to this world of semantic web ontology implementations what we've learned with the Unified Foundation Ontology and our experiences with the ONTO-ML language that have infused this. So that's what I like to share with you guys today about how to build better ontology implementations with this thing we call gUFO. In doing this and coming up with ontology implementations, it's very clear, not only ontology implementations, system implementations as well, but in particular ontology implementations, we need all the help we can get. So any kinds of support systems or frameworks or reusable artifacts can be welcome. If they have high quality, they can improve our implementation. So I'm going to tell you about 3 of those kinds of things that we can use to help us in building ontology implementations in semantic web, and they are based on the foundation ontology that influences us to come up with these reusable artifacts. So the first thing that I will show you guys is how the reuse of definitions and rules in the foundation ontology, which is then captured in an implementation of the foundation ontology, can help us in identifying problems with our own domain ontologies or whatever core ontologies that you develop in the semantic web. And here there will be, the famous sentence by Jim Handler that a little semantic goes a long way. I will focus then on these very small rules that we can take from, very simple rules that we can take from the foundational layer, and it can help us to identify problems in our models, in our domain ontologies. In our domain ontology implementations, as I will show you. And then we'll see how we can reuse a little bit more than just this little semantics, and try to understand how the reference ontology can give us some patterns that we've used throughout the years in the ONTOML language, and that can help us in creating better implementations in the sense of more stable implementations, or implementations that address some implementation challenges in the very simple semantic web languages that we have that pose some implementation barriers. And these conceptual patterns help us to come up with, to identify these recurrent solutions in a sort of standard way. So Giancarlo has even in the first technical session discussed some of these patterns in the scope of the ONTOML language, and I will go a little bit deeper here in some of these patterns. And the third thing is that the semantic web language particularly, and I'm here talking about OWL, has only identifies classes, basically. I mean, it only, your model ends up being a set of classes plus the properties and so on. And we can do more by identifying different sorts of classes. And we can have then some automated error detection that we cannot have if we just using plain OWL. So I'll go through each of those things, but before, we need some background. So first of all, this is a team effort to come up with the gUFO. So I have to thank Giancarlo for not only the background work, but specifically for cooperation in gUFO. Ricardo Falbo, whom we've heard earlier, Renata's homage to his work. He has had a very important influence not only in our research group as a whole, but he cooperated closely with us in the development of gUFO, and he was someone who had this view on the simplicity of things, that we could simplify. And this is very important because the background of UFO is one of a very rich foundation ontology, and we needed to adapt to the semantic web environment. We needed something simpler, and that was always something that Ricardo had a very clear eye for. So I would like to acknowledge this as a very important influence on this work, and thank him for that. And Tiago and Claudenir have been updating the ONTOML language for ONTOML2 language, and they have been supporting us with tools and implementations, and they have a very good eye for implementations, so they've been an integral part of this work, and this work has fed back to ONTOML. I'll later tell you a little bit more about this. Of course, there are many other people that worked on UFO throughout the years. So maybe you're all acquainted with this, but just to set the basic, before I can go through these 3 points that I set out, we're talking here about a foundation ontology, and if you're not familiar with this term or you haven't come across with that yet, just understand that the idea here is to capture the very general notions that are important in any domain ontology. So these are domain independent notions that will help us to build ontologies in any domains. So things like objects, aspects of objects, types of objects, parts of objects, events, situations, particle relations, etc., etc. So these are very basic notions, and because they are very basic notions, they will be reused. And this is what we can do by establishing a foundational layer in our ontology implementations. Another thing that is important to set as a background here is that I'm using this term ontology implementation, right? So what I mean here is then what has been called in some literature as computational ontology. So this is an ontology codified specifically here in OWL for our purposes, right? And I want to distinguish that from an ontology as a conceptual model that does not sacrifice any of its domain adequacy for implementation purposes, right? And implementation then will actually do some of these, will trade some of that domain representation adequacy for computational properties. So we're talking here about an implementation in semantic web technologies. And this is reflected in the relation between the foundation ontology we adopt, which is the unified foundation ontology, and the implementation of it in OWL, which is the gUFO, right? So G here also, the idea is that it stands for gentle UFO, so a lighter version, a version that you can directly use in implementations, and it will make some trade-off between what we have in the full theory and what we have in the implementation, right? So there will be some minor things that are different, but which are important for implementation purposes. And also the word gUFO is out in Italian, so it's a nice pun that we identified, and also because we use punning. So it's a pun, and we use punning, and gUFO is owl in Italian. So there are many, references there. So the approach we have is to have then the gUFO in this domain-independent layer. Yes, it's a joke with many levels, and then we can create our gUFO-based ontologies. Typically domain ontologies, but they could be core ontologies. Doesn't matter. Whatever is more specific than these very broad notions that are captured here in gUFO. So there are then two taxonomies in gUFO that are important for us here. The taxonomy of individuals and the taxonomy of types. And then whenever you create, the proposal is then to create domain ontologies as a specialization of one of these taxonomies and instantiating classes in these two taxonomies. So those that know UFO will recognize the taxonomy here. So individuals are classified into abstract or concrete individuals, which are further classified into endurance, events, situations. Endurance further classified into objects, and existentially dependent entities called here aspects. So you will see that there are terminological differences with respect to UFO. These differences are purposeful. So here we have decided not to use the original moment term that was used in UFO since back in the reference publication, Giancarlo's PhD thesis, because we understand that some of the philosophical jargon can pose a barrier for usability in ontology implementations. So we've chosen some terms that are more familiar to developers. That was an explicit choice that we've made. And in addition to, okay, this is not the full taxonomy of individuals. This is just a very high level overview of it. In addition to the taxonomy of individuals, we have the taxonomy of types, and these were called universals in Giancarlo's original in most UFO work. Here we call them types because of the familiarity of this term with conceptual modelers, and we have a number of distinctions for the endurance types, which those of you who know the ONTOBRAS language will recognize the ideas of kinds, phases, rows, subkinds, and all kinds of non-sortal types as well. So this is just a very broad overview of the taxonomy for you to understand the backbone of gUFO. And then I'll go through those aspects that I discussed with these three opportunities for building better ontologies with this gUFO artifact. So we thought of it always as a very simple thing to use. So you can simply import gUFO into Protege or a top grade composer, whatever. It's available there on a permanent URL, and you just whenever you do that, you import all the taxonomy that I was referring to before into your model, and you can start specializing this taxonomy with your own classes and so on. And you'll see that there are definitions for all of the terms. Very detailed documentation, and also documentation or reference documentation online. And then you can start, building your own model based on that. So here we have, for example, that persons and persons is a subclass of object, and marriage is a subclass of an aspect, which is actually an externally dependent or relational aspect, and earthquakes are events, and so on. So here it's just one of the ways you can create your domain ontology by identifying what kinds of classes that you should specialize in your domain ontology. And because of that, then you reuse some rules and definitions that are available there in the foundational layer. So here's really just something we can gain from getting the little semantics that's incorporated in this taxonomy of individuals, basically, and that will already make us go some way. So to exemplify what we gain from doing this, from just specializing these very abstract notions in the gUFO layer, let's take very basic rules that are encoded in gUFO, right? One of these is that types and individuals are disjoint. And another one is that objects and events are disjoint, right? They don't come out of the blue. They come from important features that objects and events have and that types and individuals have. And because of that, if you would have, if you would create a domain ontology and you would subclass those disjoint classes, that means that your model is inconsistent, right? There's nothing that is both an event, according to the theory that we're employing, there's nothing that is both an event and an object at the same time. So this is rendered, your domain model is rendered inconsistent, and the tool tells you that, right? But these are kinds of examples which people can think, oh, but that's so obvious. I will never make this mistake in my domain ontology. Nobody will make these mistakes in there. This is just something we don't even need tools to identify. And to show why that's not the case, I will show you an example of a real world occurrence of this problem in Wikidata. Right, Wikidata is this very massive, millions and millions of items and many classes structured in a number of ways. And here we have some of these problems that you can have if you do not have even these basic rules that are established in the foundation layer. And in Wikidata, these are not there, so there is no such a support that we can have from a foundation layer, and here's one of these problems. So here we go. I will walk through this model by showing you different items that are related in Wikidata. And the most specific one is trophy here. And if we look at what is a trophy for a wiki in Wikidata, right? And we see here, trophy is a subclass of award. Okay, and at the same time, we see here something which we'll have to understand the semantics And and it's quite confusing because it says it's an instance of physical object. Let me just say that maybe somebody made a mistake here, or we don't really understand what's the semantics of this. But let's suppose that someone is saying that a specific trophy is a physical object for this point being, right? We'll come back later to understand this even further. And so a trophy, so if you have a trophy, I can put it here in my office, and I have a trophy in my office. And it's an award by this classification here. And an award is a recognition. Right? We're just rebuilding here what the Wikidata folks have done by collectively building up this knowledge base. And recognition is the act of recognizing or being recognized. So here we already see where the problem is going to, right? And the recognition is a subclass of identification, which is itself, aside from the terminological difficulties, right? Now a trophy is a connection. So the trophy in my room is a connection. And an identification then has its own definition. And then we see that a connection is a subclass of action and occurrence. So here we go, something which someone had the intuition of saying that was somehow a physical object is now an action, because that's what the model is telling us, right? That's what the structure is telling us. So there's a problem here of some kind of inconsistency, because an action is something that an agent can do, right, or perform, and that's not a physical object, is not that. So if we would just, that's where a very little semantics of the disjointness between endurance and events can already tell us something, right? So if you would just model this by extending gUFO, or other foundation ontologies that also capture this, like BFO, for example, you would see that the model becomes, when you turn on the reasoner, you see that there's no way that we can have any instances of trophy, because it is a subclass of event and object, and these are disjoint. So the reasoner tells us that trophy is equivalent to the empty set, basically, that there cannot be instantiated. And you can have it explained to you why not, based on the various, based on the various axioms that you have included, or the structure that you have in your model. So here we see that from all these explanations that it generates, it tells here that endurance and event are disjoint, and trophy, because of this chain that we have identified of subclassing, is an event, and it's at the same time an object, and an object is an endurance. And so here's the explanation why our model is wrong. So a little semantics gave us the identification of these problems, which are not identified currently in a reference, basically in a very important knowledge base. But maybe I made a mistake in that interpretation, and maybe you said, no, they really mean that this is an instance of physical object. And if you look at the definition of physical object, actually it is a first order class. So trophy being an instance of physical object means that trophy is a physical object, not that its instances are physical objects. So it's even worse than I was considering so far. So trophy is a subclass of award, and hence it's a class. But it's at the same time an instance of physical object, which is, according to Wikidata, I'm not going to show you all the way up the hierarchy, but it is a first order class. So its instances have to be individuals. And that gives us a contradiction. So again, if we would use this, if we build, again, using gUFO, a very simple model here, we would see that something like trophy cannot be both an object and an event type at the same time. So again, there will be an inconsistency, that the very simple one to detect by the reasoner, and we'll have to face the fact that we have a problem in either the classification of trophy as an object, or as a classification as a subclass of event and instance of event type. And again, there's a formal explanation for why this is a problem, because it boils down to the individuals being disjoint from types, and they're being classified under these disjoint categories. Okay, so in addition to these very simple things like disjointness in the taxonomy, we also have a number of object properties and data properties that are reusable. So anything which is a concrete individual, like an object or an aspect or an event or a situation, will have temporal boundaries that you can establish using reified time points from all time, or using XSD, date time, and date data XML schema data types. And you can also relate objects or aspects, endurance in general, to events. So you can say when an object was created or terminated. Oh, sorry, in which event it was terminated or created, and in which event objects participated, and in which events aspects are manifested. So as in the discussion in the previous session, if you had a disease being manifested in some episode, like a fever episode, for example. And this can be just reused in your model. So either by specializing them or by using them directly. And of course, they are defined with domain and range and some meta properties. And there are also relations between situations and events, which could be used, for example, in the last work we saw in the technical session, that there were situations related to events. So this would be directly applicable there. So in the first opportunities identified here for reuse, they're pretty simple. Reuse of the foundational layer by specializing and by inheriting the rules, and also by using the object properties and data properties that are established there. I just showed some very small part of those properties here. And some of other opportunities for reuse, they will come in patterns that I will discuss with you now, and which indeed appeared earlier in Giancarlo's talk, some of them here. So the point here is little semantics, okay, can take us a long way in identifying problems, but we can even go further in terms of reuse and opportunities for building better implementations. So some of these patterns, I would just identify here 3 patterns to discuss with you. The first one is quality reification. So qualities are those aspects that are intrinsic to an endurance that normally we talk about as attributes of objects or features of objects, and which can be identified with some kind of data type, basically, right? To simplify, since we're talking here about implementations. And gUFO, you can have different ways to represent qualities, from a very simple one to a more complex or full pattern, which is that of quality reification. And I'll show you that that is used to provide us some stability in the face of changes in the model, in particular here, because qualities like weight or color or shirt size, location, they can be measured in different ways, so with different measurement schemes. And these reference schemes normally will lead to different attributes in a conceptual model or different data types. So we have to, if we can cope with that and with the change in those data types, then we can have a more stable model that can endure those changes without much impact. Another one, that was one of the things that Giancarlo discussed in the context of analytic relationships earlier, is relationship reification. So that we treat these aspects that we call relators as entities on their own. And by doing that, we can address changes in relationships we can address an area or analytic relationships, and we can also do what is called relationship qualification. So earlier in the first session, Martin Gies was saying that, you should, I think it was him, that you should pay attention that binary relations or relationships, they do not stay binary for long when you have to address other aspects of your model. And this is normally addressed by doing reification of relationships and qualifications, that you can say what you know about some relationship, or how or when it applies, so you can qualify a relationship. You can say, for example, the period of time in which that relationship holds. And not only that John is married to Mary unconditionally, but there is a period in which that happens, and that they may be divorced and so on, and their marriage may change. At one times they may change some properties of that relationship. And also, we need to address something which is in OWL not addressed at all explicitly, which is how various properties of objects can change in time. And that applies to objects and also to aspects. So, for example, someone's symptoms may become more severe in time, or some objects may change the roles they play, the phases they play, their constitution, and so on. So these are not very well addressed, and are very simple things, like a person can change his or her weight, and that's something that's not well addressed in OWL in itself. So we can have a way to cope with that as an implementation challenge that is well grounded in a foundation ontology. So as I mentioned, different ways to, there's a range of ways to capture qualities from a very simple data property, as we would do in any regular OWL ontology, that you have a data property, and that data property will use some XML schema data type as a range, and some class like physical object as a domain. And then you say that physical objects, they can have weight, which will be represented using XML schema double literals. And here the only thing we add to this very simple data property is that you can reuse and specialize the has quality value property that is in gUFO. Now that's very simple, right? That's not much different from what most people would do anyway, right? It starts becoming a little bit more involved when you have reified quality values. So when your quality values are not these XML schema literals, but they're entities on their own. And then you use object properties instead of data properties, right? And these can be used in case you need to enumerate the instances, for example, small, medium, large, extra large, or shirt sizes, or when you have structured values into components, like the triplets that you can use for RGB color, or hue saturation and value color, and so on. And you can even go one step further, and that's the full pattern that I'm going to discuss here, which can give you this stability, which comes from ONTOYML already. And that gives you that when you refine quality, and you also refine quality values, then you have a way to disentangle the qualities from the quality value space, and you have a more stable resulting model. So maybe you've seen this in the scope of ONTOYML, those that have been exposed to that, that when you refine those qualities that in here in some object, here is the physical object, the apple, that has a color and a weight, and then you can take the color of this apple, see here, and give it a value in some value space. So here we have, that particular shade. I mean, that's a terrible shade for an apple. I'm sorry, but the thing is, maybe in some model you define that this is RGB, the color, but then in another model or in another database, or in some other representation scheme, color can also be conceived of as a value in the hue, saturation, and value space, brightness space, HSV or HSB. And they are the same colors out there for you to establish. But now there's a different way to do. But this C is the same color, right? And you would lose this distinction if there would be just two data types, two data properties associated directly with physical objects or apples, right? So in the full pattern, what you have is that you have specialization of the gUFO layer. Here we have physical objects and color as a quality, and you have that color of that apple being reified here, the color. And then the color can have different values in different spaces. Here the color, the RGB space and the HSV space. And these values, they can be structured into components by reusing the has value component property. So here we have now a way to separate the color from the ways we measure color. So by identifying explicitly reified quality values, we can do that. And we can add different values for that color if we need to, by introducing new quality spaces. We can also, in addition to quality reification, I mentioned relationship reification. So here we have the example of the classical example, Giancarlo even mentioned it, of John and Mary's marriage. And the marriage is this thing which mediates John and Mary, and that is called here a relator. And this is a way for us to capture the various properties that John and Mary's marriage may have, and also a way to have all kinds of dynamic aspects here. For example, by being a relator, and a relator being an endurant being a concrete individual, we have that John and Mary's marriage as may have a temporal boundaries identified, right? So it may have started at some point and ended at some point in time. And it can have all kinds of properties. It can have different phases or roles and so on. For example, we can relate John and Mary's marriage with events, like, for example, a divorce, which is a kind of event. And so John and Mary's divorce may be identified and represented as an event with the participation of John and Mary, and maybe even others like the judge or the lawyers and so on. And it will terminate. So these are reusable relations that I mentioned earlier, which are participation in events, and the relation between endurance or concrete endurance here and events which create or terminate it then, and so on. So this is one of the reasons why we reify this, that we can qualify things like the termination or the beginning, when, for example, if we understand legal obligations as arising from a contract, the signing of a contract will be an event that will create this binding, this binding agreement between various parties in a contract. So we've been using this notion for a number of different domains, very importantly, legal relations and service relations. Another reason why we want to reify here, for example, Mary's employment at the university. So Mary here is an employee of the Federal University of Espírito Santo, and we can qualify that by giving also qualities to these relators. Since relators are endurance, they are concrete individuals, and they can be also further qualified. So here we can choose any qualification, any scheme for qualities for also applicable to relators. So here we combine quality support with relator support. And finally, for the patterns, there are a number of things that can change in our domain and which are not properly addressed in semantic web, which gives us no specific sort of native support for change in time. Right, all the facts are out there to be described, and there's no way to tell us how to represent all those situations when, for example, a person loses or gain weight, or when some object like a rental car go through different phases, or when collectives or complex objects change their composition, like for example when a band changes its members and still remains the same band. So what was who were the band members of the Beatles at some point in time, and so on. What we simply have is a way to describe various facts, let's say, but not any particular way of telling us how these can evolve in time. So here we do that with situations. So the taxonomy of individuals includes here a number of types for situation. I will only address some of them here to give a flavor of what it means to have these patterns. So I will do that by expanding on that example shown earlier with Mary's employment. So Mary's employment mediating Mary and the Federal University of Espírito Santo. And then now we don't want to be as simple as saying that Mary has a salary of 10,000 Brazilian reais. We could have used the quality pattern here to say that there are different ways that you can have a salary in Brazilian reais or in USD dollars and so on, just like the different kinds of ways to represent color that we have discussed here. But now we want to say that salary can change in time. So instead of saying just in a completely unqualified way that she has a salary of 10,000 Brazilian reais, we're saying that there's a situation where that is the case, and that situation being a concrete individual, it has reusable elements for us to determine when they begin and where they end. So here, that's Mary's salary beginning in the 1st of January 2017 and going until, sorry, this should have been 2018, going to the end of 2018. And that was, 10,000 Brazilian reais. And then, but Mary's employment is also in this other situation from 2019 on. And without yet defining a final date for this situation, we may presume it's a current situation. And there was a salary increase of 20% here. So this is a way that you can use situations, the various kinds of situations that are already foreseen, and one of them is the so-called quality value attribution situation, which is those two situations in which Mary's employment is involved are used. For the final thing we can gain from having this foundation layer, and this is a particular feature that is that we have not seen in any other codification of foundation ontologies in the semantic web, is to include even more semantics. So if Jim Handler says, right, a little semantic goes a long way, I would like to add here that some more semantics goes further, right? And this further is where we have been going further with the OntoML language, which is the identification of different types of types. So that's why we have a taxonomy of types in addition to a taxonomy of individuals, which is common in for example, BFO includes a taxonomy of individuals in its OWL codification. But here we also have, in addition to that, the taxonomy of types. So this gives us the opportunity to understand that not all classes are the same, right? So this is like we put some glasses on, and these glasses tell us, look at classes in a different way and identify those different kinds of different sorts of classes that there can be. And these are, directly consequence of our using gUFO, of course, of codifying gUFO, because that's a basic feature of gUFO. And this is a feature that you will have seen in OntoML diagrams as represented by the various stereotypes. Right, so just to be very, very quick here, there are different sort of classes. For example, the kinds, which will partition all of our domain into classes which are disjoint. Right, so here there's nothing that can be a person and an organization at the same time. There's nothing that can be an organization and an enrollment at the same time, and so on. Right, so these are the basic elements which we use to identify basic classes that we use to identify objects as being distinct. And more abstract classes can exist, which are the non-sortals, and they will classify entities of different kinds. So here I'm just showing you an OntoML diagram just for those that are familiar with that, but also showing a kind of the taxonomy that we may want to specify in an ontology implementation in the semantic web. All right, so here we have these abstract things like named entities, things that we give name, and these may be people or organizations. And so named entity classifies things of different kinds. These are called non-sortals in the theory. And here customers can be personal customers or corporate customers, which is a famous pattern that Giancarlo defined with this idea of row mixins. So here these are non-sortals which capture the common features, the common relational features of persons and organizations when they stand in contracts with contractors and so on. So then you have, your model is always then a layer of kinds, and then those more abstract non-sortals, classifying entities of different kinds. And then you have the more specific things than kinds, which are the sortals. Kind is also sortal, but these are the sortals which are specialized kinds, which include rows, phases, subkinds. And I will not discuss the details, their differences, but just that they will inherit the identity criteria from kinds. So they can never specialize more than one kind, because nothing can instantiate more than one kind, right? So there are these basic rules underlying the model that will be able to transpose into a semantic web world, even though the semantic web world doesn't allow us to, in principle, right? Doesn't give us directly a way to talk about phases and rows and categories and so on. It just gives us a construct of classes. But we can do that by, providing a taxonomy of types and having, elements here which instantiate those things. So here we have person as a kind, employee as a row, earthquake as an event type, and so on, right? So we can use the taxonomy of enduring types here to identify those same things that we identify as stereotypes of a UML class diagram in the previous slide. And then we can do the same things that we do in OntoUML, but then here now in our environment and in Prodigy. So we can have all these rules that will allow it to operationalize basically what OntoClean's rules and which are captured as OntoML synthetic rules in OntoML environment. They reflect the theorems in UFO. So if you want to see formal proofs, etc., you can find that in our ER 2018 paper. The important thing is, once they are converted into rules that we can apply on a gUFO-based domain ontology, there's no formalization that's needed. There's just a verbalization of what can go wrong in a model. And the tool then, which is a Prodigy plugin that we're developing, there's a prototype of that, can tell you when your model offends those rules. For example, if a sorter specializes more than one kind, there will be an alarm ringing. If they're rigid types, specialized anti-rigid types. I don't have time to go through the details of why these are the cases, but there are a set of rules that can identify problems in your models. So I'll just show you one of these here that you could have. So here I have what I have is very simple example with agent and specialization of agent, which is person. And for some reason, whoever modeled this considered that agent is a phase. So for example, that would reflect an intuition that someone can be an agent at some point in time and not an agent at some other time. For example, if they are unconscious or if they are dead, for example, right? Suppose that this is the case, if someone considers that. And then at the same time, they specialized this phase agent with a person kind. But if person is a kind, then they are necessarily a person, right? But if they are an agent, then they could be that they are not an agent anymore in some counterfactual world or in the future, so on. So these are inconsistent things that person as a kind is a subclass of agent as a phase. And if this is the case, then you should rethink your concept of agent or your concept of person. So maybe a dead person ceases being a person and still exists somehow, right? So I will comment later on, Marcel, on your concern. And here we can validate those gUFO rules by invoking the plugin, and then there will be a verbalization of the problems that are identified. So here, this verbalization is telling us, as a sortal, the phase agent must specialize one kind, and it doesn't, right? It's just specializing directly object here. Person is a rigid type and hence cannot specialize any anti-rigid type in particular. Here it's specializing agent. And there, you can click and go to the place where this is offending, just like any IDE would do for you. And as a kind, person cannot specialize a sortal, right? Because sortals would have inherited their specializations from a kind, and a kind cannot specialize another kind because every kind is disjoint. That would be a contradiction, a logical contradiction. So this is a plugin that takes us to the world of a semantic web ontologies, the same advantages that we have when we use OntoML in an OntoML environment. Some of them, right? Okay, so there's a verbalization of those problems in the model. This is available for download and use in Protege. It's still in the very initial development stage, but the basic OntoML rules are implemented. And finally, you can combine the things that I discussed. So you can combine identifying meta classes, like saying that persons are kinds, that person is a kind and that student is a role, and saying that persons are objects by subclassing the taxonomy of individuals. These are things that can be combined because they are possible in OW by using a putting mechanism. Same thing that you can do for endurance types here, you can also do for event types. So we can say, natural disasters are events, and earthquakes are natural disasters, and natural disaster and earthquake are, event types, and so on. This is very important because there's a very important phenomenon called multi-level modeling and the existence of the so-called high order types. And when we studied this back many years ago, we found that 17,000 of those of classes involved in hierarchies of multi-level hierarchies. This means that there's here a level of individuals in Wikidata. These are examples from Wikidata, like this ship. And then there's the notion of ship, and there's this notion of ship type. So supercarrier is an instance of ship type, and USS George Washington is an instance of supercarrier. So there are multiple classification levels. So you want not only to talk about those things here called first order types, but you also want to talk about the high order types, because otherwise you leave out all these important things from that we want to represent. So for example, here we may want to capture things that apply to person, roles, in general, like to students and professors and managers, and then say that John is a student and that Mary is a manager and so on. So in addition to specializing the taxonomy of individuals, instantiating the taxonomy of types, you can also specialize the taxonomy of types, giving you those access to these multi-level models. And you know, some of you that know the multi-level modeling MLT work that we've done in the past and we continue to support, there are things from that theory and that work that are infused here, for example. So you can say that person role categorizes person, in that the subclasses of person will be instances of person role. In fact, all instances of person roles are subclasses of person by virtue of saying that person roles categorizes person. So conclusions is that we need all the rules we can get. Let me emphasize this. So anything, all the help we can get. So any rules, any opportunities for reuse, for patterns, and for automatic quality control that we need, that we can get, we should use. And this is just leveraging our work that was already benefiting OntoML users to semantic web implementers directly at the level of ontology implementation. An interesting benefit here is that in OWL, differently from UML, there's a better integration between UFO's taxonomy of types and taxonomy of individuals, because we have putting support and multi-level modeling support in OWL. So some of the problems that people had earlier, because they were confused on, am I specializing UFO or am I using your OntoML language? These disappear in this implementation. So I know many people will be satisfied by this because they've had problems and they looked for us in the past to understand what was going on. So this is now much smoother in this implementation. And this is feeding back OntoML 2.0. And we also can solve this problem in OntoML 2.0, the great work that Tiago and Claude are doing. For those of you who are wondering, how does it fit in what we already have, right? So we have a transformation that is the work of Tiago, Claude, and others, that is incorporated in the Visual Paradigm plugin for OntoML. So you can generate gUFO-based ontologies from an OntoML model if you want. The benefit of that is that if you're using OntoML as a starting point, you can do simulation in OntoML, you can do anti-pattern detection in OntoML, and then you can generate all those things that are already artifacts, computational artifacts that are already simulated, and you already identify those anti-patterns and so on. We also have work on doing access to relational data using gUFO from OntoML models. So I see Tiago is giving us the links for the plugin if you want to install and so on. We have used the altDL fragment, which means we can obviously not express all the things that are expressed in the formalization of UFO, but that's a purposeful thing, right? You do that so that you can do some reasoning. And so it's a choice that we leave out some of the expressiveness of UFO, and some of this expressiveness that we used when formalizing UFO, they end up in the plugin, which does check the shape of your gUFO-based ontologies instead of doing the reasoning. Right? So this is some of the things that we had to do to trade off between expressiveness and the computational features that are available in OWL and in the reasoners. About what we're currently doing, part of this work that I'm discussing here is funded by a CNPq CAPES project, where we do the publication of water quality data in the Rio Doce River. The Rio Doce River was involved in a massive environmental disaster / crime from a mining company. There's a lot of water quality data that's spread about all kinds of metal in water and so on. And we're defining an interesting gUFO-based ontology for that and integrating data into what will be a data portal for water quality in the Doce River. There is the development of the plugin also includes part which is about building your models from the patterns, some of those that I discussed. This is very much work ongoing by a master's student. Things that we want to work on include the reverse engineering of gUFO-based or regular ontologies to OntoML models, and also many of the things that we've done in the last years, that there can be versions of them, operational versions of them in implementations based on gUFO. So some of the things that we'll be doing in the short term is to release gUFO C and gUFO legal aspects and the service aspects into operational gUFO-based ontologies. Some of the links that you may find useful, I will put them on the Discord channels later as well. These include the reference documentation. It's fully documented reference document for the language, for the ontology, and also a repository of all the artifacts there. And there are links to videos on how you can import gUFO into Protege and Top-Rate Composer, and also the experimental plugin that we're developing. So, and for a final message, let's not do bad ontologies. So life is too short for bad wine, bad coffee, and also bad ontologies. So I'm looking forward to your questions and comments.
Well,
congratulations, João Paulo. It's great presentation and great project and delivery. I was wondering about how much you have tested this application with real ontologies.
Yes. So the largest one we have is of this project. It's also online, the Doce River project. It should have about 100 to 200 classes, because there are a number of classes in the related to the various things that we measure in the river, like all kinds of quality kinds, many of them. So this is the largest application so far that we have, is for this water quality.
But how complex are the relationships?
Yes, that's so. The things that I've shown you here, the kinds of things that I've shown you could have been expressed with our EL. So if we just focus on this disjointness between classes, and so the things that I've shown under 1 and 2, they can be easily implemented even with less expressive fragments that are very tractable fragments, right? And the rules that I've shown in part 3, that are those underlying OntoML, these are just polynomial time, so this will be very easy to scale up, and they're currently implemented just in the plugin as the Java rules in the Protege plugin. So if you're worried about, and I know you are because you're dealing with very large ontologies, Mara, you can always choose as a computational effort what kinds of restrictions or rules you want to leave out, right? And then choose a profile which is simpler. The other approach that we can use is to do access to relational data, and that's why we have a transformation from OntoML to gUFO, and also the transformation from gUFO to relational data. That's the ER paper that we just published this year. And by doing that, you can do things like ontology-based data access with ONTOP to access the relational data. So this is another approach that you can do to lose, then do no reasoning, but have access to data that is properly structured according to the ontology, but not be
That's
burdened
interesting.
by the reasoning. Yeah, that you use the reasoning in the as a design time, that you incorporate the rules in the design time, but then at the runtime that you just use regular technologies, non-semantic technologies, let's say, but that are infused with the design work that you've done earlier.
It is a lot of advances regarding to ONTOBRAS and the previous effort. I can see that you have been working hard. Okay, I let the audience to ask.
There are some questions on the chat, right?
Yeah, would you like to read yourself? Would you like that I can read?
Please select which ones that, I think the first one was Fernando.
Yes.
Okay. So the gUFO implementation is available. Oh yeah, so Giancarlo answered through some links. There's some links of the repository and everything. Giancarlo placed there. There in this document. Let me go back to this. So in the reference documentation, there the patterns, for example, the quality patterns are discussed there. The situation patterns are discussed there, and other patterns that I have not discussed are available there. So either following this reference that Giancarlo placed this or the permanent URL, you get there. And there, the other, I will put all those links later on the Discord. So Fernanda is asking about MLT notions. I think she asked this earlier in the talk. So so yes, the answer is yes, but since this is a very simple version, which only include categorization and partitioning, which are two ways of that higher order type can be related to the so-called base type. And the rules are not yet in the plugin, but they are very, very easy to incorporate because the whole groundwork is established here. The key thing is that we use punning here, right? That so that person is an instance of type and a subclass of individual in the end. And this gives us
a great insight.
groundwork.
Yeah, this was great. Yeah, I like it very much.
Yeah.
Thank you.
So I think this solves the problems that I know you were facing, and Maria Luisa were always asking us about, what am I doing here? And we discussed, right, Fernanda, in some meetings that this was one of our, points of anxiety that we're able to solve with gUFO. Yeah. So I'm glad for that advance. Claudemir is clarifying also about this. Great. So Marcelo brought up something very interesting midway. This when I explained about, let's see, Marcelo, maybe you can remind me exactly the point it was. I think it was around here. Marcelo, can you elaborate on your earlier question? Okay. Oh, it was about anti-rigid type. Okay. Oh, yes, I know now. It was when I was saying that there was, that you could have, basically when you said anti-rigid, when I mentioned anti-rigid classes at some point. Wasn't that? Marcelo, are you there? Okay, let me just address this here. We're not precluding punning, right? We're precluding something that is classified as an individual according to the gUFO taxonomy from being a type as classified in gUFO taxonomy. Right? So that does not preclude, on the other hand, it's actually the opposite. We're actually doing that. We have here classes are entities, are all things, and so are individuals. So we do not partition those things. But you cannot say that something like trophy is an individual in the sense of being a concrete object and being a type. So this is what would be a problem, right? Of course, trophy here is a class, and the model in Wikidata was just plain wrong, and we're just revealing that it was wrong by showing the contradiction. I hope it addressed your question. And João is then has a question here about the classification levels. So where are the boundaries? How do you choose where to go from foundational to core or domain ontologies? Where are the boundaries? And where do you choose the appropriate level when designing an ontology? For example, some argue that elements like time and space should be covered in foundational level, while others in the core level or in the domain level. How to measure the specificity of a term, the red line, for example, disaster events.
That's a hard question.
Yes, I think that's a design question that relates to the classes of applications you want to support with your ontology. And there's also arguments of cohesion that you can use to justify what you put at least in the same layer or in the same level. So I think it will be a matter of deciding. I think that there are also a matter of the labels we use, whether something is foundation or not. Doesn't matter much, right? I think there's a spectrum here, and that we navigate this spectrum by deciding which parts of them are reusable for a class of applications that we have in mind. It would be nice to have some more guidelines as you're hoping for, and I hope we can come up with those guidelines at some point. But that's an interesting topic for research, I would say.
Okay, thanks, Dr.
Great. Rafael's saying temporal dimension, right? What about the spatial temporal problem? Do not address that here. So far, what I'm doing in for example, the Doce River model, I need to address that, right? Because I need to have a spatial features, because it's about the river out there and we're doing measurements in different points of the river. So this is now just an additional quality that is included, which is locational. And because of being a quality, and you may question about whether that's good from an ontological perspective, I'm not questioning that. I'm doing a pragmatic approach, taking the qualities and using that for location. And then you can have locations of different granularities, and you can reify also spatial regions. What is done there are good practices for that from the spatial data working group on the W3C, something like that. I don't remember what it's called. And you can just use these features here, because you can have both something very simple as two doubles for latitude and longitude as very simple qualities that I discussed before. So you just have two data properties that specialize, that has quality value data property, or you can have something more sophisticated where you reify those regions, and you can have relations between spatial regions and things like the containment and so on. So we just leverage, I would say, just leverage the quality support that we have for spatial features. João Lima is asking then about the situations where Mary has her salary increase. To record the event that defined the salary. To the hiring event and then the raise, right? The salary raise. Yeah, that's possible. We can do that, because there's this relation between, that's a good suggestion for modeling. I was just coming up with an example. That's a great example to add to this here, because that's a choice that you may want to have, because these situations here, they can be related to, this was brought about the raise, right? So we can just take the relations between, the possible relations between event and situations, to say that situation raises this situation. So that's a very nice example to complement this. Great. Thanks, Fernando, for your interest. And Marcus, why gUFO does not consider situations as a snapshot of reality? Yeah, so this is, as Giancarlo mentioned in the first session, there's a number of ways. We're even doing some work discussing. Now we're discussing with with Nicola and Ricardo in Italy, how we're going to approach this. So far, approaching situations in this way seems to be more comprehensive. So we wrote a paper on what called scenes and situations, and these here, they would be analogous, these situations in gUFO would be analogous as scenes in that work, in the sense that they expand in time and they can have these properties over time, they can change over time. So these are understood as variable embodiments. They can extend, not only extend in time, but they can have their properties changing and so on. So this is ongoing work where we thought that if we had snapshots, then how would we do things like this? Whether we qualify the situation that stays in that way for some time. I hope that answers your question. Yes, please, Barry, you can do that.
Yeah, I would ask to Barry to take the microphone.
Yes, so I sort of enjoyed that talk because I agreed with nearly everything.
I love your qualification of sort of like my talk.
Yeah, the problem was that I agreed with too much, so I like to disagree. Okay. But there was one point where I would like to raise an issue. Yes. So it's at the very end. You said that we need reuse. And if you're dealing with complicated ontologies, and I think both gUFO and BFO are quite complicated already, then very few people are going to be able to reuse them because they need to go through a difficult training program. And even people who go through that difficult training program very often still make mistakes. So you say, therefore, we need all the rules we can get. And I agree with that too. But I think the rules should be easy to teach.
Yes. Okay.
And
good.
And the one place where UFO and gUFO differ from BFO is in your acceptance of higher level types or classes.
Absolutely, yeah, that's a very important difference.
In my experience, people make a lot of mistakes when they allow higher level classes. I mean, users. I know that UFO doesn't make mistakes like that. I thought it did at the beginning, but Giancarlo persuaded me that I was wrong to think that you were making a mistake with upper level classes. Okay. So, but I still claim that people make a lot of mistakes when they use higher level classes.
That's a fact. That's a fact. We have empirical support for that because we studied Wikidata and we found that whenever there were multi-level taxonomies, that people were making that mistakes. Yeah. So first of all, we don't need that, right? If someone just wants to use the taxonomy, that's first of all, they don't even need to use. They don't even need to subclass gUFO. They can just reuse directly by, just typing, just saying that the entities they're interested in, their objects or their events and so on, and they can just reuse those object properties. They can do this with gUFO. They can do this with BFO as implemented in now and as available, right? They can subclass the taxonomy of individuals only, if that's a very simple. So that's if you want to start. By doing that, and that's also what you can get with BFO by subclassing the taxonomy, which is there, right? Yeah. Yeah. A significant difference is in terms of the terminological choices that we've made in gUFO as compared to what is there in BFO, which is which I would consider a more harder to teach the terminology, let's say. And then you have the point that you're making, which is very important. It is not that easy to manipulate the taxonomy of types. But if you're just instantiating it, we have a story of success by using OntoYML and the stereotypes there, and people understanding the difference between kinds and the categories, for example. So if you just want to, if you want to have an incremental approach, where you just say, forget about anti-rigid types, and let's just use categories and kinds. That's already something you can gain in your model, because you can already explain them how to refactor a more complicated, Giancarlo gave some examples earlier, a more complicated model by using non-sortals, which then can more freely classify instances and so on. So I think we have a long experience now with undergraduate students and master students that we teach in OntoML, and there is a gradual, the point that I want to emphasize in the answer to your question is that there's a gradual way. Nobody needs to be doing specializations of the taxonomy of types, but if they need to do, they will hack their way in a model that does, in a reference ontology that won't give you that. They will just create objects that are actually representing types, and they will hack their way instead of reusing a base.
Do you have these higher level types in gUFO?
Yeah, let's go here. So if you say that, so kind, right?
Yes, okay.
In person and Barry being an instance of person, then this is already, I would already call this higher order type. And but if I want to say things like that, maybe that an animal species, it depends on your perception of species and so on. But if it's if you want to consider the higher order type, then you would just say that species subclass is kind and so on, and that it's something like an animal kind, and that partitions animal, and then particular animal, like that lion that was killed in Zimbabwe by the dentist, that animal is an instance of lion, and that lion is an animal kind. And maybe you want to say that animal kinds, an animal kind regularly eats another animal kind or something like this. So you may want to have properties that are captured here at the level of high order. Like, for example, the example that I gave here in this slide is that a person role can have properties like some authorization levels, so students can have authorization levels and things like this. So we explore this in some of our papers on multi-level modeling.
So I don't like your animal kind example.
Yes,
I think what we mean when we say lions eat dogs is not that one kind eats another kind. It's that every instance of lion eats some instance of dog, something like that.
Yes, I mean, these are up for debate, but people end up needing to express the general rule somehow. And there are other things like the population, whether a species is endangered or not. We want to have this in our models, right? How can we say that?
You can say that also without. So I actually approve of quantifying over kinds or types if you want to have a philosophically good ontology of what exists. I'm talking about now the problem of teaching an ontology that people will understand and be able to reuse consistently. And I think BFO is better structured for that purpose than.
Well, I hope it's the case.
Even than the gentle version of UFO.
Otherwise, you would change it. But yes, we've seen that these phenomena, these multi-level phenomena, are very important. As I can point you to the paper on our analysis of that in Wikidata, and they are talking about types of ships and types of.
I understand that. So let me give you another dimension. So Wikidata is interesting, but the US government has a gigantic infrastructure which is devoted to administration, and this they have billions and billions of dollars every year to administer many things across the government. There's something called the General Services Administration, which is the bureaucracy which deals with all of this, and they create lots and lots of classifications and categorizations, overlapping ones built by what we would regard as amateurs, and they're full of higher order types, and it's anarchy, it's catastrophe. Now they come to people like me and they say, can you help? And we try and help, and then they retire and the next generation doesn't know about people like me, and so they start all over again.
So what's your solution for
So
product
the
types
solution
and all
is
kinds of
to
inventory
make people
item types and so on?
make people feel guilty when they talk about higher level types.
So what's your solution then? What to give them as a solution for their classification schemes, for them to represent, because they manipulate their classification schemes. They are experts in their classification.
No, on the contrary. They're not even experts at their own classification schemes. They're experts at the job they need to do, but the classification systems are a kind of side effect, which they don't really care about, because when people have these big administrative organizations, they only ever care about a tiny sliver of cases which they're really good at. Then all the rest is taken care of by someone else.
So I would like to know how you address the problem that they want to manage those catalogs that they have of types.
No, I tell them they need to rebuild them. They should rebuild them on the basis of good ontological principles.
Yeah, because
and that's what they want to hear. They want to be freed from this monster that they.
I'm afraid that I need to ask you to move to Discord, because we are about. I love this discussion, but we are about to finish this session.
Very a lot. I mean,
there are some other questions in the session. I will ask people to move to Discord and put the questions there.
By the way, Mara, it's very suggestive. It's Discord, so let's discuss it there, right?
Yeah. That's the idea. So I will ask people to put the questions that is not answered in the chat, in the Discord. Then João Paulo will get some coffee break now to go there and answer, and then also Barry can go and complement this endless discussion indeed, because this is not easy point of agreement in there.
May I just make a small remark about the discussion that I found very interesting? Is that Barry is actually calling also our attention as a community to the need of more work on support for teaching ontology-based concepts. I think this is an opportunity. So since we are here in ONTOBRAS, I would like to advertise this as a good direction, because surely on computer-supported teaching and learning, there are many techniques that can be used. So just a tip.